it a groundbreaking discovery that could reshape our understanding of planets beyond our solar system. NASA's James Webb Space Telescope has uncovered compelling evidence of a massive planet orbiting a star in the star system closest to our Sun. Located merely 4 light-years away, the Alpha Centauri star system has long captivated astronomers seeking to identify exoplanets, a term used for planets outside our solar system. Alpha Centauri is a fascinating triple star system situated in the southern sky, composed of a binary duo, Alpha Centauri A and Alpha Centauri B, both of which bear a resemblance to our Sun, alongside a more subdued red dwarf star known as Proxima Centauri. Interestingly, Alpha Centauri A claims the title of the third brightest star visible to us at night, while Proxima Centauri is confirmed to host 3 planets. Establishing the existence of other planets around Alpha Centauri A and B has proven notably difficult for scientists. Recent observations made by the James Webb Space Telescope, specifically utilizing its mid-infrared instrument, MIRI, have resulted in the strongest evidence yet of a large gas planet orbiting Alpha Centauri A. This exciting finding has been documented in 2 recently accepted research papers published in the Astrophysical Journal Letters. Should this claim be validated, the gas giant would be the nearest known planet within the habitable zone, an area around a star where conditions could potentially support life, of a star akin to our own. However, due to its classification as a gas giant, researchers indicate it would likely be hostile to any form of life as we understand it. Our proximity to this star system means that any exoplanets identified here would give us a unique chance to gather data on planetary systems that differ from our own, explained Charles Beekman, associated with NASA's Jet Propulsion Laboratory and the NASA Exoplanet Science Institute at Caltech's IPAC Astronomy Center, and a co-first author of the groundbreaking papers. He further noted the challenges of making such observations. Given the brightness and rapid movement of these stars across the sky, which complicated their detection, Beekman emphasized the impressive adaptability of Webb, which was originally engineered for observing the universe's most distant galaxies. The operations team at the Space Telescope Science Institute had to devise a bespoke observing plan tailored for this particular target, and the extra effort certainly yielded inspiring results. The research team undertook multiple carefully orchestrated observation sessions, analyzed the data thoroughly, and relied extensively on advanced computer modeling to conclude that the object detected in Webb's images is likely a planet, and not an unrelated background galaxy or asteroids obscuring the view. The initial observations commenced in August 2024, employing a coronagraphic mask to block out the intense light emitted by Alpha Centauri A. Although interference from the nearby Alpha Centauri B complicated the analysis, the team successfully filtered out the light from both stars, ultimately revealing an object that is more than 10,000 times dimmer than Alpha Centauri A, positioned approximately twice the distance between our Earth and the Sun. Following this thrilling initial detection, additional data collection in February and April 2025, utilizing the director's discretionary time reserved for unforeseen opportunities, unfortunately did not reveal any traces of the object detected previously. We find ourselves confronted with what can be described as a disappearing planet. To delve deeper into this enigma, we simulated millions of potential orbital patterns using computer models, which incorporated knowledge from both the bright appearance and subsequent absence of the planet, shared PhD student Aniket Sanghi from Caltech. Sanghi is also a co-first author on the 2 critical research papers. In their simulations, the research team also analysed a sighting from 2019, carried out by the European Southern Observatory's Very Large Telescope. They combine this information with Webb's data, while accounting for gravitational stability, concerning Alpha Centauri B, ensuring the planet would remain tethered within the system during its orbit. Researchers have stated that the lack of detection in the second and third observation phases is not entirely surprising. Our simulations indicated that in about half of the potential orbits we analysed, the planet ventured too close to Alpha Centauri A and would therefore not have been visible to Webb in either February or April 2025, explained Sanghi. Using the brightness noted in the mid-infrared observations along with the orbital simulations, researchers suggest that this potential planet could be akin to a gas giant, possibly with a mass comparable to Saturn, and orbiting Alpha Centauri A in an elliptical trajectory varying between 1 to 2 times the distance from the Sun to Earth. If this planet is indeed confirmed as observed in Webb's image of Alpha Centauri A, it would signify a remarkable advancement in exoplanet imaging achievements, said Sanghi. It would be the closest directly imaged planet to its star thus far. Additionally, it bears a striking similarity in temperature and age to the giant planets in our solar system, making its proximity to Earth particularly remarkable. The mere existence of such a planet in a closely paired star system would challenge our existing theories on how planets emerge, endure, and thrive amidst turbulent environments. If further observations back up their findings, the results could significantly shift the landscape of exoplanet studies. This potential discovery would serve as a pivotal reference for exoplanet research, offering myriad opportunities for detailed analysis with Webb and other observatories. Bakeman commented, "For instance, the forthcoming launch of NASA's Nancy Grace Roman Space Telescope, expected no later than May 2027 and potentially much earlier, includes specialized equipment aimed at exploring binary systems like Alpha Centauri in pursuit of additional worlds. The visible light data collected by Roman would complement Webb's infrared findings, providing unique insights into the planet's dimensions and reflectivity. As the premier space observatory dedicated to scientific exploration, the James Webb Space Telescope is unveiling secrets of both our solar system and distant worlds surrounding other stars, while also investigating the enigmatic structures and origins of the universe at large, including our place within it. This substantial international program is spearheaded by NASA in collaboration with partners such as the European Space Agency, ESA, and the Canadian Space Agency, CSA. For those eager to dive deeper into the fascinating world of the James Webb Space Telescope, more information can be found at Learn More About Webb, https:/science.nasa.gov/web.